as I was looking at problems number 1 and 2 for lesson 5, I noticed that there were 4 things that I was considering in each problem. And as I listed that information and kind of highlighted, circled, underlined it, it became clear that if I identified those 4 pieces of information, it led me down a path to, in an organized way, solve the problem. So I'm going to compare practice problems 1 and 2 from Unit 3, Lesson 5. So this is problem number 1, and this is problem number 2. And you really only need the A part for problem number 2 to do this. So for problem number 1, there are pizzas that are being delivered. And so you have to calculate the delivery fee. They tell you that 2 pizzas cost $25, 5 pizzas cost $58. So they want to know what's the total number of pizzas that you order if you pay $80. So you have to go through and figure out the delivery fee. You have to figure out the cost per pizza. For problem number 2, they tell you up front that you have to pay $500 for the supplies to have your house painted. It's going to cost you $50 for each hour, so they're giving you the hourly rate. And they're giving you the total number of hours, and you have to calculate what is the total cost. So these problems are basically giving you the opposite pieces of information, and I'm going to show you that in a moment. So those 4 pieces of those 4 components of these problems that are linear relationships, component number 1 is identify the 2 properties. So the 2 properties for problem number 1 are the cost and the number of pizzas that you purchase. The 2 properties for problem number 2, again, is the cost, but then it's the number of hours that the painters work to paint your house. So cost, number of hours, and cost, number of pizzas. In problem number 1, you have to calculate this. You have to calculate that it's $11 per pizza. So you have to figure out some way to come up with that number. In problem number 2, it's given to you. So these are the opposite pieces of information. Number 1, you have to calculate it. Number 2 is given. The second component is there an amount of money of one of the properties before the activity even begins? Actually, not amount of money, but an amount of one of the properties before the activity even begins. So in other words, is there a value for y when x equals 0? The second property when x equals 0, which is the second property, is there a value for the first property? And so problem number 1, there's a delivery fee. So before any pizzas are even delivered, you owe $3 for the delivery fee. And you have to calculate that. You have to figure out some way to come up with that number. For problem number 2, it's given to you that you have to pay $500 up front for the cost of the supplies. So before the painters have even painted any part of your house, you have to pay them $500 to buy the supplies to paint your house. So there is an amount of property 1 before property 2 kicks in. So before any pizzas are delivered or before any hours are spent painting. And so in both cases, property number 1 is the cost. So there's an added cost in both cases. All right, component number 3. One property compared to another property in a constant way. That is the rate of change, the unit rate, the slope. All of these words basically mean the same thing. And for problem number 1, again, you have to calculate that. You have to calculate what is the cost per pizza. So you have to calculate that rate of change or that unit rate or that slope, all the same. For problem number 2, it is given to you. They tell you it's $50 per hour worked. So that's the rate of change. Every hour that they work, you owe them $50 more. Work another hour, $50 more. Work another hour, $50 more. That's the unit rate. That is also the slope. And the final component is what's the total of one of the properties. Oftentimes, that's what's the answer to the question. Sometimes it's not. Sometimes they're giving you that total. So the cost, the total cost for problem number 1 is the $11 per pizza. So it's the number of pizzas. So what's the cost for the number of pizzas that you order plus that $3 delivery fee? And so they give you 2 examples in problem number 1. One is $25 for 2 pizzas, and the other is $58 for 5 pizzas. So with this information, and this is really the only information that's given to you, you have to figure out the delivery cost, the cost per pizza, and how many pizzas you order if you pay $80. For problem number 2, the total cost is that $50 per hour times the number of hours worked, plus, don't forget, you have to add that $500 to that. And so for problem number 2, you have to calculate the total cost if they work for 20 hours. Remember, you have to add this $500 after you figure out the total cost for the 20 hours of work, which is 20 hours times $50. You have to add 500. Or for 50 hours of work, which is 50 hours times this $50 per hour, plus that $500. All right, so 4 parts, 4 components. And so what I did is I tried to simplify this into some simple phrases. So number 1, what are the 2 properties? Number 2, is there an amount at x equals 0? Number 3, is there a rate of change, which is the unit rate or the slope? Number 4, the total of one of the properties based on the other property. So you're given a certain amount. What's the other amount? And I put this into a table. So what are the 2 properties? So you fill in these 2 spaces. What's the amount at x equals 0? Fill in the space. What's the amount of the rate of change, or the unit rate or the slope? Fill in the space. And what's the total amount? Fill in the space. Now, in some cases, you're going to have to calculate these, and in other cases, they are given to you. So if you look at problem number 1 compared to problem number 2, you begin to see that they are really the opposite problems. Problem number 1, so the 2 properties are the cost in dollars and the pizzas, the number of pizzas. The second component is, there's a delivery fee. When x equals 0, before any pizzas are delivered, there's a fee of $3. You have to calculate that. What's the rate of change? In other words, what's the cost per pizza? You have to calculate that. That turns out to be $11 per pizza. And they give you, that is $25 for 2 pizzas and $58 for 5 pizzas. In problem number 2, they give you the opposite information. So the 2 properties, again, is the cost and the number of hours worked. So this cost, remember, is comprised of 2 parts. It is the cost of the supplies up front plus the cost of each hour worked. The amount at x equals 0, which is the $500, that's the cost of the supplies. So again, that's given to you. In the other problem, you had to calculate it. So what's the rate of change? So how much do you have to pay for each hour worked? $50 per hour. That's given to you. Problem number 1, you had to calculate it. You had to figure it out. And finally, what's the total amount? Well, for 20 hours, you have to calculate that. In problem number 1, that was given to you. That was the $80 for how many pizzas. And 50 hours, you have to calculate the total cost in that case. So if you calculate those total costs, it's $1,500 and $3,000. So I think if you go back to this table and have this table in front of you as you work through problems that have to do with linear relationships, this will help you a lot. It'll help you organize the information into a way in which you can efficiently, in an organized way, figure out the answer to the question that's being asked.